Okay, let's talk about all the possible ways you could solve this tomorrow on your test. You could just do it by the normal system of equations. Oh, come on. And you're going to need to pick one of these and put it on your DOM, and I want it to be accurate because we're going to take a vote in a second. You could do like a normal system of equations, although we never did that with a 4x4. I guess you could do that. You know, where you just, we only did this up to 3x3. You could do Gaussian elimination, which was where you had your matrix. You had your matrix and then a thing, and then the answers were like down here by themselves. And whatever you did to the left side of the matrix, you did to the answer column, and when you were done, those were the answers. You could do it like that. Or you could do inverse method, where you take the inverse of that matrix after you find it, multiply that by b. Or you could use Cramer's rule, which was dx over d, dy over d, or dz over d, and dw. How? How would you find the bottom variable? Oh, you mean with the triangle method thing? That's what this was. Yeah, where you got zeros below this line. You know, I'm just drawing this, and then you plug all the stuff in. Yeah, that's what that method was. Yeah. These are the only 4 ways we've worked on. Now, if this will influence you, I'm also going to require you tomorrow. In fact, let me just show you the pretest in case you didn't already look it up. You are going to be required to find inverses of matrices, so you're already going to need to know how to do that. So, if you're looking at all 4 of those methods I just wrote up there and thinking, yeah, no, then maybe the method you should choose is this one, because you're going to have to find an inverse of a matrix tomorrow anyway. So if you already have to know it, might as well use it again. So pick one of those 4. It's the only thing you could possibly use to solve this system, and I'll take a vote, because I'm not going to work this problem 4 times for everybody who wants to see everything. And I'm not going to work it like this just because I'm already going to be doing an inverse problem today on the review. So I'll choose one of whichever of the 3 methods wins that vote and solve it like that to help you prepare for tomorrow. Does anybody need me to explain any of these methods a little further before we take the vote? If you chose to do it by normal system, I'll be surprised, but if you chose to do it like that, raise your hand. 1, okay, that's fine. That's impressive since we never did it. If you chose to do it like this with Gaussian elimination, raise your hand. 1, 2, 3, 4, 5, 6, 7, 8, 9. If you chose to do it with the inverse method, raise your hand. 1, 2, 3, 4, 5. And if you chose the Cramer's rule, raise your hand. 1, 2, 3, 4, 5, 6. All right. The winner was the Gaussian, so this one right here. So I'm going to do it like that. The only thing about doing it using Cramer's rule, we never actually did a Cramer's rule on a 4x4. So you may not want to do that. You can, and there's an example of that in the book, and it just means the diagonal method is a little longer. You absolutely can do it like that, but we just never did one like that. So I'm going to do the Gaussian because that's the one that won the vote today. All right. Well, no, you should have put on your DOM what you voted for. Now we're just going to work it, and this is the beginning of the pretest. All right, first thing we have to do if we're going to do it in that method is write the thing down as a matrix. Remember, in this method, the answers go right in there with the rest of the matrix. Oops. Skipped one. Now, the whole reason I typed this out was to help your alignment. I tried to keep the W's in a row, X's in a column, Y's in a column, Z's in a column. Tomorrow, please make sure you notice the negatives and everything. I would hate to see people miss points on this. W. See? There you go. Thank you. Please beware of that tomorrow. If you want, you tell me. Would it be confusing, more confusing, or does it help if I like, let me do it on this one. If I were to like double do it like that, that would make it look like minus and negative? Alright, well then I'm just going to leave it as 1. So just, what about this? Would it be easier to see if I did it like this? Because this is how I type them out. What if I put the spacing like that? Is that preferred? So put the minus closer to the second variable? Okay, then that's how I'll do it. I'll do it like that tomorrow. Am I missing any other negatives? Okay, good. Here we go. Alright, I'll go edit that later. So, we need to get, what Austin said earlier, we need to get upper echelon. Oops, well, that's a really horrible line. Hold on. We need to get all the numbers below this line, or in this triangle, to be zeros. Luckily, 2 of them already are zeros, so it's not going to be so bad. Remember, tomorrow, today, we're already fortunate enough to have a positive 1 up here in our, I believe we call it the cockpit in this class. But you could always move your rows around as long as you move the whole thing around to put a 1 up there if there's 1 somewhere else. So remember that. Okay. Now remember, we're going to use the first row to knock out the first column, second row for the second column, third row for the third column. What do I need to do to get rid of this? That's right. They're already little, reciprocals of each other. So R1, bless you, plus R3. What's the only row that's going to change in this matrix? Row 3. Very good. So, I can go ahead and write down the other rows exactly as they are. The only one that's going to change is R1 plus R3, which will be 0, 0, 1, 2, and negative 1. When you add row 1 to row 3. At any point, raise your hand if you have a question about a step that I've taken. This is going to set up really nicely. I tried to find 2 that were extremely similar to this one for tomorrow's test. They may not work out quite as nice, but I tried to find some that were extremely similar. Okay, first column done. So now I'm down to a 3 by 3, and I need to use this number to knock out this column. Well, one of those is already a 0 too. So what's the only step I need to take now? I'd have been shocked at how I picked this one at random. I really didn't pick it because it was this easy. I should have. But then that wouldn't have been fair because only one of the tests would have had this one on it. Somebody wouldn't have gotten this problem. Okay, so what's the only row that's going to change? Row 4. So the other 3 rows are going to come over exactly as they are. And let's see, row 2 plus row 4 is going to give us 0, 0, 0. I can't believe it. I almost feel like throwing in a random number just to make this a little bit harder. Okay, nothing. It shouldn't have been this easy. Well, we're already kind of done. I can't believe this. Tell you what, at the end of the review, if we have plenty of time, I'll find a harder one. That way you can see a harder one works, because we didn't really have to do anything here. So, that's negative z equals 0, which gives us a z value of 0. We're going to backtrack that. This is going to give us y plus 2z equals negative 1. Well, if z equals 0, then this is y equals negative 1. Plug both of those into this equation, which is x minus y plus z equals 4. So that's going to be x minus a negative 1 is plus 1. plus 0 equals 4. Subtract the 1. What is this, a 3? All incorrect. And then the top equation is w minus x plus 2y equals negative 3. I'm going to work this one down here. So that's w minus 3 plus a 2 times a negative 1. So that's w minus 3 minus 2. So it's w minus 5 equals negative 3. Add the 5 to the other side, and you get 2. So your solution is 2, 3, negative 1, 0. Question. Again, I'll try to find a harder one than that toward the end so that we can see one where we actually have to do a little work. Any questions? Okay. To the review then. Here's what I actually posted online yesterday, except at the top it said you cannot use a calculator and it's not multiple choice. It'll be this exact format tomorrow. One page, everything right here on the front, and solved, basically. Okay, so I'm going to take all these and put them in inner right. The first one, a minus d times c. Can I subtract a minus d? Yeah, they're the same dimensions. They're both 2 by 3. So when I subtract a minus d, which will go into this matrix, a minus d, 2 minus negative 2 is 4. Negative 1 minus 3 is negative 4. 2 minus 1 is 1. 5 minus 3 is 2. 3 minus negative 2 is 5. And negative 1 times minus 4 is negative 5. Questions on that step? Now I need to multiply this by c. This is a 2 by 3. C is a 3 by 3. Can I multiply them? What's my product going to be? 2 by 3. Outside numbers. 2 by 3. So here we go. Yeah, I'm just kidding. Here we go. 2 by 3. Row by column. First row, first column. 4 times 1 is 4. Negative 4 times negative 1 is 4 again, so that's 8. 1 times negative 1 is negative 1. 8 minus 1 is 7. Then I take the first row by the second column. 4 times 2 is 8. Negative 4 times 1 is negative 4. 8 plus negative 4 is 4. 1 times 2 is 2, so 4 plus 2, 6. First row, third column. 4 times 3 is 12. Negative 4 times 2 is negative 8. You know what, I'll tell you what, every time I'll kind of write the numbers here. 1 times 1 is 1. So 12 minus 8 plus 1 is 5. Wonder if it's going to be 4, 3, 2. Okay. Alright, we're out of columns, so what do I do now? Next row. 2 times 1 is 2. 5 times negative 1 is negative 5. Negative 5 times negative 1 is positive 5. Add all those up. Those. Maybe it'll be 2, 3, 4, 5, 6, 7. Second row, second column. 2 times 2 is 4. 5 times 1 is 5. Negative 5 times 2 is negative 10. Negative 10 plus 9, negative 1. Last row, last column. 2 times 3 is 6. 5 times 2 is 10. Negative 5 times 1 is negative 5. 16 minus 5 is 11. And that one's done. That problem is finished. Tomorrow. Now I'm going to remind you of this tomorrow. If you notice, the way I have that test printed out, there's not a whole lot of space. Only thing I want on that paper is your answer. You can still show work on the back and on separate pieces of paper, But this guy right here is the only thing I want to see on that test. If it's correct, I'm not even going to look at the work for that problem. But if it's not, well, then I can go look for partial credit. Only thing I want to see on the front of your test tomorrow are the finished answers. Any questions about any step we did here? How we knew something, how we did something, anything? Okay. Does anybody need me to leave this up there? Here we go. Next problem, inverses. I'm going to ask you to do a 2 by 2 and a 3 by 3. Dang it, wrong button. A 2 by 2 and a 3 by 3. We're going to find the inverses of. First off, the 2 by 2. You need to have this formula in your notes. This was the formula for the inverse of a 2 by 2. 1 divided by the determinant times the scramble of the original. If you have that, then this is a cakewalk problem. AD is 0, BC is 12. 0 minus 12 is negative 12. Then we scramble. We switch these two. That becomes negative 2 and 0. Notice I don't change the signs. I noticed some people doing that in their homework. These do not have their signs changed. These two have their signs changed. So that becomes negative 3 and negative 4. And you can leave it just like that. You could multiply through by the negative 1/12 if you'd like and reduce. That'd be like 1/6, 1/4, 1/3, and 0. But you don't have to. You can just leave it like that if you prefer. Another reason you may want to use Gaussian elimination tomorrow to solve that one problem is because you're already going to have to know how to do row operations to find the inverse of your 3 by 3. So, might as well use a row operation one again. Again, it's up to you, but let me take this elsewhere. Anybody need me to leave this on the board? Alright. 3 by 3, finding the inverse. Who can tell me how you start out finding an inverse? Yes, sir. Exactly. Set it up with the identity on the other side. Very good. Now from here you can do any steps you want. My natural instinct is to try to get a 1 in that top left corner. Personally, I would start this by doing row 1 and switching it with row 3. That way I've already got a 1 up there. Yes, it might change later, but you don't have to. You could also just take a way to do it without moving your rows around would just be row 1 plus 2 row 3. That would make this a 0. Remember, our goal is to get all of these to be 1 and everything else to be 0. Now, the proper method for doing that is to get all your zeros first. Don't really worry about your 1s. And then later, go and multiply through. So, row 1 plus 2 row 3. Only row that's going to change? Row 3. So I'm going to go ahead and copy rows 1 and 2 down as they are. 2, 2, negative 1, 1, 0, 0, 0, 3, negative 1, 0, 1, 0. Alright, now we're going to double row 3, add it to row 1. It's going to be negative 2, negative 4, positive 2, 0, 0, 2. That's twice the bottom row, which I'm now going to add to the top row. 0, negative 2, 1. Should have changed colors. 1, 0, 2. Now, we need to use the middle row to get rid of the second column. We don't have a 1 here. What's a common number that 2 and 3 can go into? 6. So how about 2 row 2, 3 row 1? But we'll have to make one of those negative. How about negative 2, row 2, plus 3, row 1. That way this will be a negative 6, this will be a positive 6, and they should cancel. What about these two? 6 again, yeah. 2, row 2, plus 3, row 3, because one of those is already negative, and that should set us up nicely. Only row that's not going to change, row 2. The one not mentioned in this column. So that's going to be 0, 3, negative 1, 0, 1, 0. Alright, negative 2 times the second row. You know what, I'll write these down here. Negative 2 times the second row is going to be 0, negative 6, positive 2, 0, negative 2, 0. 3 times the first row is going to be 6, 6, negative 3, 3, 0, 0. Adding those together, you get 6, 0, negative 1, 3, negative 2, 0. That's the way I would probably do it if I were you tomorrow. Do the little rows out to the side, add them, and then just plug them in. Whenever you have to multiply both rows, it's kind of hard to do it in the margins like I normally do. Now, 2 row 2 times plus 3 row 3. I'll do those over here. 2 row 2 is going to be 0, 6, negative 2, 0, 2, 0. 3 row 3 is going to be 0, negative 6, 3, 3, 0, 6. That's the bottom row times 3. Adding those together, you get 0, 0, 1. Ooh, it looks like at least the last column's not going to be bad at all for us. 3, 2, 6. I'm going to stop, let people catch up, and I'm also going to field questions. How I knew to do something, where I looked for that, or anything of that nature. Please ask them if you got them. Well, good then. I guess we know what we're doing. Fantastic. Okay, well, there's only 2 more numbers to get rid of, and those are the top 2 numbers in the third column. And you have to use the third row for that column. So this is going to be nice and neat. What's the only thing we have to do to get rid of those? Very good. Row 3 plus row 1 and row 3 plus row 2, because they're already inverses of each other in both cases. Well, bad word choice. Reciprocals of each other. Only row that's not going to change, row 3. 0, 0, 1, 3, 2, 6. Adding that to row 2, you get 0, 3, 0, 3, 3, 6. Adding it to the top row, you get 6, 0, 0, 6, 0, 6. What's the only thing I have left to do? Reduce. And how am I going to do that, Joey? Very nice. I'm going to take 1/6 the first row and 1/3 the second row, which will give me this. 1, 0, 0, 1, 0, 1, 0, 1, man, chicken track. 0, 1, 0, 1, 1, 2, and 0, 0, 1, 3, 2, 6. When you have the identity on the left, what is on the right is your inverse. And you can stop here, or you could check your answer. Who remembers how to check your answer? It'd be nice to know if you were right tomorrow, so you could maybe put it off to when you're done, but if you got done half an hour early, you could check and see if this one was right. How can you do that? Yes, sir. multiply, well, this one didn't have answers. Multiply by the original and see if you get your identity. Would anybody like to see that? All right, then. We're going to multiply this. Does anybody have the original in front of them that they wrote down? I don't feel like going all the way back over. This was a negative 1? Okay. 0, 3 what? Okay. Okay. Now I'm just going to kind of fly through this rather quickly to see if that's the inverse. Oh. Here's my inverse, here's my original. Now remember, when you did this on your homework, it said you should do it in both directions. Well, if this is wrong, it's not going to work in either direction, so it doesn't really matter which one I check. If it works for one, it's going to work for the other, most likely. So I'm just going to go multiply it in this order. Here we go. I'm hoping that I get 1, 0, 0, 0, 1, 0, 0, 0, 1. Just like this. 2 plus 0 minus 1. 2 minus 1, 1. So far, so good. First row, second column. 2 plus 0 minus 2. 2 minus 2, 0. So far, so good. Negative 2 plus 0. I'm sorry, negative 1 plus 0 plus 1, 0. First row, down. Go to the next row. 2 plus 0 minus 2 is 0. 0 plus 3. Uh-oh. What? Oh, that's not the right thing. 2 plus 3 is 5, minus 4 is 1. I was panicking there for a second. Negative 1 minus 1 is negative 2, plus 2 is 0. So we're down to the last one. 6 plus 0 minus 6 is 0. 6 plus 6 is 12, minus 12 is 0. And lastly, and if this works out, we're golden. Negative 3 minus 2 is negative 5, plus 6 is positive 1, and we got the answer correct. Yes. Way to go, team. Questions? I believe there's only one question left on this test. What? It was the determinant, right? And you can do that by the diagonal method or the minors method. We'll take a vote here. Again, hey, you know what? We're already done. I can show both methods because I know different people use different ones. I saw people's homework, and it's about half and half, actually. So I'll do both methods for this real quick. If you choose the minors method, you take the first row. Now, if you know how to, if you do not think 3 by 3 determinants are hard, 4 by 4 are extremely similar. You should look in the book and look at a 4 by 4 example from section 8.5 and choose Cramer's rule. Solve that problem tomorrow if you wish to do so. But anyway, so minors method 3, negative 1, 0. Remember the top row putting a minus in front of the second one. Yes. No, if it's negative, it'll be minus negative, so it'll end up canceling. Yeah. So, what's the minor for the 3? Very good. What's the minor for the 1? Very good. Now, we're going to go ahead and write in the minor for the 0, but why is it not going to really matter? Because it's going to multiply by 0, exactly. We're going to go, write it down. Very good. Questions about where any of that came from? Here we go. Negative 20 minus 0 is negative 20. 3 times negative 20 is negative 60. Minus negative 15, positive 15 minus 0. So 15 times 1, so it'll be minus 15. I didn't actually put in, I just did positive 1 times positive 15. So our determinant is negative 75. If you chose to do the diagonals method, then you would have written down your first two rows again. And here you go. 3 times 4 times negative 5 is negative 60. 1 times 0 times negative 1 is 0. 0 times negative 3 times 3 is 0. Add all those together. Subtract the other directional diagonals. 0, 0, and 15. Positive 15. Oh, that's right. Thank you. Negative 60 minus 15 is also negative 75, so you can do it either way. Remember, the negative 75 is the only thing I want to see on your stinking paper. Show your work somewhere else. Keep these things neat so I can get them graded quicker. I don't like playing Where's Waldo with their answer. It's a pain. The test is done. I'm glad you thought so. Raise your hand if you would be in favor of seeing a more complicated four variable system. If you would like to see one, because most likely the one I picked out isn't going to be that simple tomorrow. Now, if you understand that what we're doing, then I guess it doesn't matter. But if you would like to see a more complicated four variable system, raise your hand. Okay. Okay. Well then, in that case, our review